Hello dear students, good evening to each and everyone. We are studying signals and system in comprehensive manner, and already we completed total 3 lectures in this course. Every day I am taking classes at 5:30 p.m. As of now I am taking only 60 minute or 60 to 75 minute class. Later on from next weeks I will take class for mod. Fine. So mod duration guys. Duration I will increase. So first of all tell me, audio and video both are clear or not? Am I audible properly? Tell me in the comment box guys, am I audible properly? Audio and video both are clear or not? So this is lecture number 4. And in the last class guys, we have seen the different properties of an impulse function. Okay, and I completed the area property and the scaling property. Okay, and I provided you some examples in homework guys. Okay, so tell me what is the answer guys here. Tell me what is the answer. If you have solved this question, then tell me what should be the right answer of this question guys. What is the right answer? So you have to draw x of t guys. X of t is equal to 1 by 5 L minus 6 t minus 1 by 2, correct? So here scaling factor is minus 6. So x of t 1 by 5 into 1 upon mod minus 6 del t minus 1 by 2. X of t is equal to 1 upon 30 del t minus 1 by 2 guys. This impulse located at t equal to 1 by 2 having total area 1 by 30 guys, or we can say height of the impulse. So here this is at 1 by 2. What is the height? Height is 1 by 30. Clear to each and everyone? Fine. Yes, 1 by 30 del t minus 0.5. Yes, your answer is correct. Now one more example I gave you. One more example guys. So here draw x of t guys. Draw x of t. So here scaling factor is 2. So 2 del 2 t minus 3. Correct? So x of t which is equal to 2 into 1 by 2 del t minus 3 guys. 3 by 2, sorry. T minus 3 by 2, correct? You are taking scaling factor 2 common. So x of t is nothing but del t minus 3. This impulse is located at 3 guys, having area 1 guys. Amplitude is infinite, area 1. Remember this thing. Okay, here area is 1, amplitude is 3, correct? So this is the answer of question number 4. Fine. Del t minus, sorry, 3 by 2, my mistake guys. Here 3 by 2 is there, my mistake. By 2 is there, 3 by 2 guys. So it will be at 3 by 2, my mistake guys. 3 by 2, yes, of course. You are taking 2 common, so it is 3 by 2 guys. So this impulse is located at 3 by 2, 1.5 guys. 1.5, clear to each and everyone? Fine guys. So this is question number 4. Now, okay, this is the based on property, 4th property guys. Now next property guys, see the next property, product property guys, product property. So this property says any general signal x of t is multiplied with impulse located at t naught. Any general signal x of t is multiplied with impulse located at t naught then it is nothing but impulse only, guys. Impulse only, same impulse, but now its area is different. We can say weight also, guys. See, one more word is there. So here you can say, here, see guys, here you can say this is the weight of this impulse, guys. This is shifted and weighted impulse, guys. 1/30 you can say weight, or we can say height, or we can say weight of the impulse, guys. You can say area of impulse, or you can say weight of impulse, or you can say height. So this is known as weighted impulse, guys. This is what, guys? Weighted impulse whose weight is 1/30 and it is shifted. It is right shifted, guys. Correct? Right shifted from the origin. So here it is nothing but the resultant is what? A weighted impulse, guys. Here resultant signal is what? Weighted impulse, that is x of t naught, x of t value at t naught to del t minus t naught, guys. So x of t naught is nothing but what? What is x of t naught? X of t naught is nothing but x of t value. X of t value at t equal to t naught. Correct? This is the property, guys. This is the property. Now you can prove this properly very easily, guys. Very easily, guys. If you want proof directly graphically, you can prove, guys. Suppose this is general signal. You are multiplying impulse located at t naught. Then what is the resultant signal, guys? What is the resultant signal? So here this is t, guys. So let us consider this is any general signal, correct? And you are multiplying with this general signal with del t, guys. Here the area is 1 or weight is 1, location is t naught. So this is nothing but del t minus t naught, and this is your signal x of t, guys. Now here this value is t naught, and at t naught, this point here, this is nothing but x of t naught, guys. Correct? This is t naught. So here amplitude of x of t is nothing but x of t naught, guys. So if you multiply these two signal, guys, simple multiplication, you can see here greater than t naught. So this multiply by 0, it is nothing but 0, guys, and less than t naught. So this multiply with 0, it is nothing but 0. So the resultant signal will be impulse only, guys. At t naught, it is impulse only, guys. Here you can see at t naught the resultant signal is impulse only, but weight is different, guys. Weight is different, same location, but weight is different. Now here see, this is 1 and this is x of t naught, guys. Here amplitude is x of t naught and this is 1. So its weight is x of t naught, or area is x of t naught. The impulse located at t naught, so that's why del t minus t naught. So this is the impulse, guys, located at x t naught. So del t minus t naught. Now weight, what is the weight or what is the area? So here x of t naught and here 1. So x of t naught into 1. So x of t naught into del t minus t naught, guys. So this is very much important property, guys. This is very much important property, product property, and different result from this property, guys. Different results from this property. So here different result if t naught is equal to 0, suppose x of t into del t, guys, del t. So here you can see what is t naught. So t naught is 0. What is the answer? So here weight is x of 0, x of t value at origin, del t. Correct? So this is very much important result, guys. Suppose I am writing here t into del t, guys. T into del t. So t into del t, here t naught is 0 and you have to put this value here, guys. Correct? Here you can compare with this, guys. If you compare with this, so t naught equal to 0 and you have to put this t naught value in this x of t, guys. X of t equal to t. So it will be 0 into del t, which is 0. So what finally we can write, guys? So t into del t, nothing but 0. So these are two important results. Okay. One more result. In general, guys, the first result, the second result. Okay. This is the first result. Okay, this is the second result. Okay, this is the second result, guys. Here you can write t into del t equal to 0. Now third result, in general, suppose x of t into del at into del a into t minus b, guys, at minus b, correct, at minus b, then what will be the answer, guys? So first of all, before using product property, first of all you have to use the scaling property, guys. First scaling property, then other properties, guys. So first scaling property, what is the answer? What is the answer, guys? So here x of t to del, scaling factor a common, so t minus b by a, guys, okay, which is equal to x of t into 1 upon mod a del t minus b by a. Now here t naught is equal to what, guys? You can see t naught is equal to b by a, तो यहाँ पे वैल्यू पुट करोगे, ये टी नॉट की वैल्यू आपको यहाँ पे पुट करें, तो फाइनली रिजल्ट x of t into del at minus b, which is equal to 1 by mod a. Now x of t, but value is what, at b by a, guys. X of t value at b by a into, don't forget this one, into del t minus b by a, first located at b by a. So this is very much important result, guys. So x of t into del at minus b, which is equal to 1 by mod a into x of t value at b by a into del t minus b by a, guys. Correct? Fine. Is this clear? Clear to each and everyone? Fine. So this is very much important property, and this property name is product property. Now if you integrate this property with respect to both the side, integration, do integration of this equation with respect to t both the side, then it will be, then it become sampling property, guys. It becomes sampling property. Now we know that the product property x of t into del t minus t naught is equal to x of t naught into del t minus t naught. Now perform integration with respect to t both this side, minus infinite plus infinite x of t into del t minus t naught into dt with respect to t, guys. So here integration minus infinite plus infinite x of t naught into del t minus t naught dt, guys. Correct? T minus t naught dt. Now this is the constant value, guys. This is the constant value, x of t value at t naught. So as this is constant, you can take outside the integration. You can take it outside the integration. So integration minus infinite to plus infinite x of t into del t minus t naught dt, which is equal to x of t naught integration minus infinite plus infinite del t minus t naught dt. Now what is the answer of this one, guys? This is the area under impulse, guys. Location of impulse, whatever it is, but area always 1, guys. So here area of impulse is always 1, guys. Area of impulse is always 1. So the final answer, what is the final answer, guys? So integration of minus infinite to plus infinite x of t into del t minus t naught dt, guys, which is equal to what? X of t naught. This is the very much important property, guys. Here integration, we are doing integration from minus infinite to plus infinite, guys. So integration minus infinite to plus infinite x of t into del t minus t naught, which is equal to x of t naught, guys. So simply here t naught value from here you have to put in x of t, guys. Put t naught value from here into x of t, then it will be your answer. Now important result, here integration limit is infinite, that is minus infinite to plus infinite, but suppose finite integration result from this property, guys. Important result, So number 1, we are doing integration from T1 to T2 guys, x of t into del t minus t naught dt. Then again answer will be x of t naught, but this time this shift t naught should lies between the given integration limit. This t naught should lies between the given integration limit, that is if t1 less than or equal to t naught less than or equal to t2, then and then we can say answer is x of t naught, and if it lies between outside the integration limit, if t naught lies outside the integration limit, then the answer is 0 guys, otherwise. So this is very much important result guys. Okay, so integration t1 to t2, so answer is again x of t naught, but this t naught should lies between the given integration limit t1 and t naught. If t naught lies outside the integration limit, then directly you can say answer is 0. So this is very much important result guys. Any doubt in this? Any doubt till here guys? Fine. Okay, is this clear? I hope all the students are getting what I am saying. So this is very much important guys, this is very much important result. Okay, and don't worry, we will solve number of questions based on these properties guys. Okay, now this is what sampling property. Okay, in sampling theorem we will use this property. Now next property is shifting property guys. Okay, so again this property also can derive from the product property guys, product property. So product property is what? X of t into del t minus t naught, which is equal to x of t naught to del t minus t naught. Okay, now let t naught is equal to tau. Okay, t naught equal to tau. So x of t into del t minus tau, which is equal to x of tau into del t minus tau. Okay, now integrate both this side, do integration both this side with respect to tau. Now guys, integration with respect to tau. First we are replacing t naught with tau, then integration with respect to tau. Okay, with respect to tau. So if you do integration with respect to tau, integration tau is from minus infinite to plus infinite x of t del t minus tau d tau, which is equal to integration tau is from minus infinite to plus infinite x of tau into del t minus tau d tau, correct, t minus tau d tau. Now here you can see guys, so integration, the interest variable of interest is what? Tau guys. Here variable, integration variable is tau, and here variable is t guys. So this is constant with respect to t guys, x of t is constant with respect to tau, constant with respect to tau guys, with compared to tau this is constant, so you can take outside the integration. So it will be x of t, now integration minus tau is from minus infinite to plus infinite del t minus tau d tau guys, del t minus tau d tau, which is equal to integration minus infinite plus infinite x of tau into del t minus tau d tau guys. Now again here you can see guys, what is the area under impulse guys? This impulse is located at tau equal to t guys. Here variable is tau, so this impulse is located at tau equal to t. So what is the area under impulse guys? Again area under impulse is 1 guys, area under impulse is 1. So here finally we got any general signal x of t can be represented in weighted and shifted impulses. Any general signal x of t can be represented in weighted and shifted. Weighted, so this is x of tau, that's why weighted, and this is shifted guys. Del t minus tau is shifted impulse, and here we are multiplying x of tau, so this is weighted and shifted, and integration is there, that's why impulse is correct. So any general signal x of t can be represented by weighted and shifted impulses guys. So this is very much important property guys. very much important property. It is also derived from the product property, but here integration, first we are replacing tau with tau, t naught with tau, the integration with respect to tau, and in previous integration with respect to t, guys. Here we are doing integration with respect to t, and here integration with respect to tau. This is the only change, guys. So this is very much important property, guys. This is very much important property. This property again we will use while studying the continuous time convolution. Continuous time convolution. Okay. So I will start continuous time convolution from this property only, guys. Okay. So this is very much important property. Remember this thing. Remember this thing. Okay. Now what are the different results from this property, guys? So let us take, let x of t is u of t, guys. U of t. Then here it is u of t, guys. U of t integration tau is from minus infinite plus infinite. This is u of tau, guys. U of tau del t minus tau d tau. T minus tau d tau, guys. Now we know that this u of tau, guys, this u of tau is 1 for tau greater than 0, and it is 0 for tau less than 0, correct? Tau less than 0. So if you replace u of tau with 1, then the limit of integration become tau is from 0 to infinite, because for tau less than 0, that means from minus infinite to 0, u of tau 0, then that's why hence answer is 0, correct, for tau less than 0. So it will be u of tau will be tau is from 0 to infinite. Here this is 1 del t minus tau d tau. So this is very much important result we got. U of t is 0 to infinite del t minus tau d tau, guys. Very much important result we got. Okay, this is very much important result. So step function is integration of the impulse function. This is the first format. Now let us derive second format also. So here what we got? We got u of t, nothing but tau is from 0 to infinite del t minus tau d tau. Now let us consider lambda is equal to tau, guys. Lambda is equal to tau, then d tau will be d lambda. Okay, and here as tau equal to 0, here let us consider this t minus tau equal to lambda, guys. Okay, so minus d tau equal to d lambda. This implies d tau equal to minus d lambda. Now as tau equal to 0, for this what is the lambda, guys? Tau equal to 0, so lambda is t. As tau equal to infinite, then lambda is, if tau equal to infinite, so lambda is minus infinite. Then here in integration, this is u of t, guys. U of t integration lambda is from t minus infinite. This del lambda into minus d lambda. Now if you interchange the limit of integration, then this integration become minus, correct, if you interchange the limit of integration. So u of t is nothing but minus lambda minus infinite, lambda equal to, simple math, guys. If you interchange or change the integration limit, then minus you have to multiply, guys. So of course, so here minus del lambda d lambda, correct, and this is minus sign. Now this minus and this minus, it will be plus, this minus and this minus plus, guys. So it will be u of t will be integration lambda from minus infinite, lambda is from minus infinite plus infinite d lambda del lambda d lambda. Now again let us consider here lambda is equal to tau guys. So d lambda is equal to d tau, correct? So it becomes q of t, which is nothing but same. If lambda equal to minus infinite, so tau is minus infinite to t guys. Sorry, my mistake. Minus infinite to t. Minus infinite to t del tau. Simple maths I am using guys. Del tau d tau, correct? So two result we got guys. Result number 1, q of, and if you differentiate guys, if you differentiate this guys, so d q of t by dt, then here it is what differentiation and become del t guys, correct? So first order differentiation of step function is nothing but what? Unit impulse function guys. If you differentiate impulse function step function with respect to t, it will be del t guys. Differentiation with respect to t guys. So what we got guys finally, first result, u of t is nothing but 0 to infinite del t minus tau d tau. Second result we got, if you replace t minus tau with lambda, the integration minus infinite to t del tau d tau. Okay, and third result we got, the differentiation of this unit step function is nothing but impulse function. This is very much important guys. Any doubt in this? Tell me, any doubt? Fine. Clear to each and everyone? Tell me guys. Clear? Fine. So here these three are the important result. These three are the important result from this property. Okay. So finally, let me summarize all the things. Guys. Summary of all the property. Summary. So first guys, first is area property. So area under impulse is always 1. Second property is scaling property. Del alpha t is equal to 1 upon mod alpha to del t. Okay, and here result from this property, if alpha equal to minus 1, then del minus t equal to del t. Del minus t equal to del t, correct? Del minus t equal to del t, that is impulse is a even function. Third is product property. So x of t into del t minus t naught, which is equal to x of t naught to del t minus, correct? T minus t naught guys. And result from this property, first result guys. So t naught is 0. If t naught is 0, that is x of t into del t, which is equal to x of 0 to del t guys. Clear? Okay, this is the first result. Second result we got t into del t, which is nothing but 0, correct? Because here t naught equal to 0. If you put t naught 0 here, then it is and their answer is 0 guys. Then fourth property, sampling property, minus infinite to plus infinite, x of t guys. Here one more result is there, ki x of t to del a into t minus b dt guys, minus b, then it will be 1 upon mod a x of b by a. So x of t, so t value at b by a guys, x of t value at b by a into del t minus b by a. Okay, you can take a common, then t naught equal to b by a, put here, so x of b by a into del t minus b by a. So these are the three results from third property. Here x del t minus t naught into del t. So this t naught you have to put here, then it will be x of t naught always. Here integration limit is minus infinite to plus infinite. But if integration is from T1 T2, then what would be your answer, guys? Del T minus T naught dt, which is equal to, again answer it can be x of T naught, but only when if this shift lies between the given integration limit. T naught lies between the given integration limit, the answer is x of T naught. Otherwise, if it is outside the integration limit, then answer would be. So this is the first result, guys. Okay. Now next is last is shifting property. So again, any general signal x of t can be represented in, here tau is from minus infinite plus infinite. Weighted and shifted impulses, guys, x of tau into del t minus tau d tau, correct, d tau. And important result, if you put x of t equal to u of t, so here u of t limit will be 0 to infinite, guys, because u of tau, so u of tau limit will be 0 to infinite, u of tau equal to 1 del t minus tau d tau. Now del t minus tau equal to lambda, then you will get the second result, u of t is nothing but integration minus infinite to del tau d tau. And third, differentiation of this unit step function is nothing but unit impulse function. So this is the summary. This is the summary of, correct. This is the summary of properties of impulse function, guys. Properties of impulse function. Got it? So this is very much important. Okay. And this much you have to write in your short notes, guys. Please make a short note, proper short note. You have to prepare proper short notes of each and every chapter, each and every subject, guys, for each and every subject. Okay, because at the last you require revision part, and in revision this short note will be very much helpful. Okay. Now let us solve some questions based on this important properties, guys. Important properties. Okay. So first you have to apply the scaling property, then you have to apply the remaining properties, then use the remaining property. Okay. So let us start with very first question. This is already we have done. Now question number 5, guys. So what they are asking, what is the value of this integral, guys? What is the value of this integral? Okay. Now in GATE exam they will not mention that this is the question from the signals and system and this is the question from the very first chapter and use here impulse property. Okay. By looking this question, first you will come to know that I think it can be a question of engineering mathematics, but no, guys, this is the question of signals and system and based on the property of impulse function, guys. Okay. So here solution. So here what is the T naught, guys? Here you can see, guys, this is your T naught equal to 5 and this is your x of t, guys, correct? So x of t, so you have to put T naught here. Now minus infinite to plus infinite, so this 5 lies between minus infinite to plus infinite. So T naught equal to 5 and just put or just replace t with 5, guys. Here just replace t in x of t with this 5. T become T naught and T naught equal to 5, guys. So integral answer I is equal to, tell me, guys, tell me. So here e to the power minus a t square and here this t equal to T naught and here T naught equal to 5, guys, correct? So here I will be integral will be e to the power minus 25a, guys, minus 25a. So answer is e to the power minus 25a. More than sufficient. Okay, these sessions are more than sufficient to crack any competitive exam in which this syllabus is present, guys. Syllabus of signals and system is present. Okay, GATE as well as ECE as well as bar DRDO. Okay, more than sufficient. I will cover each and every topic in very much detailed manner with sufficient number of questions. Don't worry. But you have to attend all the classes very much sincerely and you have to do sufficient number of self practice also, guys. Like you can solve PYQs of all 3 branches, ECE, electrical, GATE previous year questions of ECE, electrical and instrumentation. Then you can solve previous year question of ESE, ECE and electrical, and these questions are more than sufficient to increase your confidence. Okay, to increase your confidence. Fine. Now let us try this question, guys. Try yourself and tell me what is the right answer for this question. What is the, solve this integral, solve the integral I and tell me what is the correct answer for this question number 6, guys. Tell me what is the right answer for this question. I am expecting answer from each and every student. Okay, so how to solve this question, guys? So again, see here, T naught, guys, here if you compare with standard format, so T naught is equal to 6, put this T naught here, so the integral value will be, so x of t is square and you have to replace this t with T naught, which is equal to 6, guys, which is equal to 6, and this 6 lies between 0 and infinite. Definitely you can use this property, guys. Okay, so integral I will be 36, guys. So 36 is the correct answer of this question, guys. 36, fine. So 36 is the right answer for this question. Let us solve this question, guys. Let us solve this question. Solve this question and tell me what is the correct answer for this. What is the right answer for this question? Okay. So here now your x of t, correct? Sin phi t will be your x of t, and here if you compare with standard format, the t naught equal to 0. So this t naught you have to put to integral value sin phi pi t at t equal to t naught equal to 0, guys. The integral value I is equal to, correct, integral value I is equal to कितना हो जाएगा, 0 हो जाएगा. Okay, so here sin 0 0 हो जाएगा, तो आंसर आ जाएगा बिग 0, करेक्ट, आंसर आ जाएगा 0, guys. So 0 is the correct answer for this question. Okay, now let us solve some more question, and gradually I will increase the difficulty level also, guys. Difficulty level. Now try this question, question number 8, guys, and tell me what should be the correct answer for this question. What should be the right answer for this question? What should be the correct answer for this question? Tell me. So again, see here, यहाँ पे कंपेयर करोगे तो now this time t naught equal to -2. Put here, guys. So integral I will be integral I, guys. So here t to the power -2, and here t naught equal to -2. So answer is power 4. Okay, and if it is numerical answer type question, they want to write numerical value of e power 4, guys. E power 4 numerical value, guys. E to the power 4. What is the correct answer? E to the power 4, guys. E to the power 4. 54.59, guys. 54.59. correct? So here 54 guys, answer 54.59. So 54 here, which is equal to 54.59. So answer is 54.59 is right answer for this question. Okay. Now try this question guys. Try this question. Del t minus 2 whole squared del t minus 2. I think there is mistake in this. So del t minus 2 into del t minus 2 whole square. Something is missing in this question guys. Something is missing. Okay. So just leave this question as it is, because here del t minus 2 whole square del t minus 2, this is not possible. This is not possible guys. Otherwise answer should be 1 guys. Answer is 1 guys. Okay. So here I is equal to integration minus infinite. So here del t minus 2 whole cube dt. So area under impulse is always 1 guys. Area under impulse is always 1, and square of impulse also impulse guys. So that's why answer is 1 guys. If you are considering this data, then the answer should be 1 guys. Answer should be 1. So 1 is the right answer for this question guys. Clear? Okay. Now let us solve one more question. Question number 10. Question number 10 guys. Del t e power minus j omega t dt. What should be the right answer of this question? Tell me in the comment box what should be the correct answer. And I am expecting answer from each and every student. Question number 10. Here T naught guys, you can see naught is equal to 0. Okay, in this slide is minus is equal to plus in fact. Here guys, it here is equal to e power minus j omega t or t naught equal to 0 guys. E power 0 कितना हो जाएगा 1 is 1 guys. E power 0 is 1. Answer is 1 guys. So 1 is the right answer for this question. Now let us solve next question. Question number 11. Question number 11. Now this is very good question. So you have to solve this integral. Now limit of integration is finite, that is minus 1 to 8. Then what is the answer of this integral I? I am expecting answer from each and everyone in the comment box. So I am expecting answer from each and every student guys. Tell me what should be the correct answer for this. So here first of all you have to use the scaling property, time scaling property of the impulse function. Integral I minus 1 8 del t plus 3 into dt minus 2 integration minus 1 to 8, and here the scaling property guys. So 1 by 4 del t dt, correct? Can you do like this? Okay. So minus 1 to 8 del t plus 3 into dt minus 2 minus 1 to 8 1 by 4 del t dt. Now here see, here this t naught guys, you can see guys, here impulse is present at t equal to minus 3 and you are doing integration from minus 1 to 8 guys. In this here, if I am talking about this one, So impulse present at -3. Impulse is present at -3. Right? Impulse is present at -3. Correct? Impulse is present at -3, guys. -3, and you are doing integration from -1 to 8, guys. You are doing integration. You are doing integration from -1 to 8, and impulse is present at t plus 3, guys. So what will be the answer, guys? You are finding area between -1 to 8, and here there is no signal, guys. Amplitude is 0, so that's why answer is 0 for the first integration, guys. Answer is 0. Okay, and in second impulse is present at origin, guys. Second case, impulse is present at origin. For this case, impulse is present at origin. Impulse is present at origin. Del t origin, and you are doing integration from -1 to 8, guys. So of course, now the property you can use, guys. So integral I is equal to, then I is equal to, answer of first integration is 0. This is -2 into 1 by 4, and integration of impulse is 1, guys. Correct? 2 into 1 by 4, and integration of impulse. Okay, area of impulse from -1 to 8 is 1. So that's why I is equal to -1 by 2, guys. -0.5 is the correct answer for this question. Clear? Yes, -0.5 is the correct answer for this question. Very good, guys. Now let us solve next question. Now this is also very good question, guys. Tell me what is the correct answer for this question number 12. What is the correct answer for question number 12, guys? What is the right answer for the question number 12? Right answer for the question number 12. What is the correct answer? Anyone in the comment box? So again same. So here T naught is equal to 1, guys, and you have to put T naught here. So I is equal to T plus cos phi t, and here T is equal to naught is equal to 1, guys. So I is equal to 1 plus cos pi into 1, guys. So I is equal to cos pi 1, so 1 minus 1 हो जाएगा 0. So answer is 0. So answer is 0 for this question, guys. Correct? Answer is 0, guys. So 0 is the correct answer for question number 12. Now let us solve next question number 13. 13, guys. Now this is also very much important. So before applying sampling property, first of all you have to use the scaling property. I told you, guys. First you have to use scaling property, then use the remaining property. Okay. So first use scaling property and tell me after that what is the value of T naught? What is the value of T naught in this question? I am expecting answer from each and every single student. I am expecting answer from each and every single student. So I equal to minus integration minus infinite plus infinite square. Okay, square. Okay, so integration minus infinite to plus infinite square. The del scaling factor is minus 1 by 2. Minus 1 by 2. So this is t minus 1. Correct? T minus 1. Fine. T minus 1. Just wait for a minute. चलिए ऐसा हो जाएगा. So sorry, -1/2 you can take common, guys. -1/2 you can take common. So here it is t minus 1, guys. Now the scaling property, guys. So here integration minus infinite to plus infinite t square 1 upon mod -1/2 del t minus 1 dt. Okay. So I is equal to minus infinite to plus infinite. So here 2 times t square, guys, correct? 2 times t square into del t minus 1 dt. Now you can see t naught is equal to 1 and put it here, guys. So I is equal to, from this I is equal to, so here t square, so 1 square it is 1, so 2 into 1 square is equal to 2, which is equal to 2. So answer is 2 for this question. Clear? This is very good question, guys. Answer is 2. Any doubt in this question? So 2 is the correct answer for this. 2 is the right answer. Now let us solve question number 14, guys. Let us try this question. Tell me what should be the correct answer. This is also very good question. This is also very good question. Tell me what should be the correct answer. Again, -1 scaling factor you have to take common. So integral I, integration minus infinite to plus infinite. -1 scaling factor -1, 1 upon mod -1 del, so t minus 1 del t minus 1 into t cube plus 4 dt. करेक्ट. तो मैंने -1 कॉमन ले लिया. वैसे भी सॉरी, लेट अस टेक -1 कॉमन, गाइस. तो I is equal to minus infinite to plus infinite. This is 1, guys. Del t minus 1 t cube plus 4, guys. Cube plus 4 dt. So here t naught, what is the value of t naught, guys? T naught is equal to 1. Put it here, guys. T naught is equal to 1, guys. Put it here. The answer is 5, guys. I is equal to 1 cube plus 4 equal to 5. Correct? So 5 is the correct answer. Got it? Any doubt in this? Here 5 is the right answer for this question. 5. Okay. 5 is the correct answer for this question, guys. Now let us solve this question number 15. Question number 15, guys. Now this is very good question. This is very good question. But before that, you have to understand the sinc function, guys. Sinc function, no issue. You can solve it. This is very good question. This is very good question. What is the correct answer for this question? This is very good question. Okay, here T naught is equal to, here see T naught, here you can see guys, T naught is equal to 0, not equal to 0, you have to put here. So this x of t is nothing but sin kt by t, and here t is equal to, T naught is equal to 0. So what is the answer at t equal to 0 guys? So here you can see, you can write like this, is nothing but limit t equal to 0 means t tends to 0, t tends to 0, can we say like this, sin kt by t guys, sin kt by t, yes or no? Can we say like this, sin kt by t, x of t equal to limit t tends to 0, sin kt by t, sin kt by t, correct? Now sin theta by theta, sin theta by theta is equal to 1 guys, but here theta equal to kt, so in denominator also it should be kt, so k divide by k and multiply by k guys. So x of t is equal to k limit, here also you can write kt tends to 0 because opposite tends to 0, so t tends to 0, k2 tends to 0, both are same, sin kt divided by kt. Now sin limit theta tends to 0, sin theta upon theta, so the value of this limit is 1 guys, value of this limit is equal to 1. So here x of t guys, x of t which is equal to k into 1, so answer is k. Here x of t reduced to using the property. Okay, so this is very much important question guys, very much important question, fine. Okay, now let us solve now next question, question number 15 guys, question number 15. Now x of t into del t guys, x of t into del t, what should be the correct answer? X of t into del t guys, so here x of t del t, okay, so here t naught equal to 0, here answer is x of 0 into del t guys, correct? Remember this, already we have seen in the result of the product property guys, t naught equal to 0, so answer is x of 0 into del t guys, and if you integrate both this side with respect to t, answer will be x of 0. Okay, so here answer is x of 0 into del t guys, x of 0 into del t guys, fine. Now next question, question number 17. In the similar way, what is the answer of this question guys? What is the answer of this question? So here again same thing, so t naught is equal to what guys? The value of t naught is equal to 1, so x of t not equal to 1, so 1 square plus 2, and don't forget this del t minus 1, don't say answer is 3 guys, it is 3 into del t minus 1 because integration is missing. Okay, simple product property guys, simply here you have to use the product property, correct? Product property you have to use, so x of t is equal to, this is 3 to del t minus 1, answer is not 3, remember this, if you are writing answer is 3 then it is absolutely wrong, because here this is the product property, integration is missing, so that's why del t minus will come into answer guys, so this is very much important. Okay, okay, so here answer is 3 into del t minus 1 guys, answer is 3 into del t minus 1. Okay, so these are the different questions based on the properties of continuous time impulse function, or it is also known as direct delta function. You can solve similar more number of questions guys. Okay, so here I am finishing this lecture, And in next part, we will see more different standard signals like rectangular function, triangular function, signum function, sync function, SA function, sampling function, then sine function, different functions we will see. Okay. So all of you, thank you so much watching me on Wallah live channel, and next part we will continue in subsequent module, and please provide your valuable feedback about this class in comment box. Thank you guys. Thank you so much.